Good afternoon, folks. Right. First of all, for those of you who keep saying to me, why don't you check this link? Why don't you check that link? Why don't you check that over there, or what this guy said, or what that person did? You'll learn something. No, I won't. I don't need to look at anything else because I have the solar eclipse in the sky. Now, I'm going to go one step further today. See all this, right? See all this paraphernalia? That is the sun radiating its light, and it's taking 8 minutes and 20 seconds to get to the moon. And then 1.3 seconds later, oh, my freaking planet Earth has done one. Sweet spot. Okay. So, as seen, what's happened there? It's like the sun's doing one as well. Now, I have spent the last couple of hours, right, going back and forth, trying to work this out, okay? Back and forth, this 8 minute and 20-second light delay. Because from here, when we are positioned on the sweet spot, which is right here, and we're looking at the moon, and we have the sun directly behind the moon, there's this problem of the 8 minutes and 20 seconds. Because in 8 minutes and 20 seconds, the sweet spot on planet Earth, like what I'll put this here, right? That means 2.08 degrees. So you see the blue line, give or take, it doesn't have to be exact. It means that the photons left the sun when the sweet spot was 2.08 degrees away from where it's going to be during the solar eclipse. Now, 3, 2, 1, go. Photons left the sun, that water, right, in slow-mo, and it's traveling. Bang! In that moment, what do we see? We see the moon and the sun directly behind the moon. Now, listen up, folks. This is not possible. It is a paradox. I said I'm going to go one step further. I am going to go one step further. If it took photons 8 minutes and 20 seconds to arrive here from the sun, we would never, ever see the sun in the sky. It's impossible because the photons that are here left that sun that's in the sky 8 minutes and 20 seconds ago. So what are we seeing in the sky, and why is it directly behind the moon during a solar eclipse? Question mark. It is an absurdity. I'm calling it right here, right now. If it takes 8 minutes and 20 seconds for Mickey Mouse photons to get here from the sun, we would never, ever see the physical sun in the sky, let alone directly behind the moon as seen from the sweet spot on planet Earth during a solar eclipse. Guys, you do not understand the science. It's a fact. It is not possible. It cannot play out like that. We would never see the sun. It would always be light, but we would never see the sun, ever. pure logic. So there you have it. We wouldn't ever see the sun because it's always 8 minutes and 20 seconds ahead of where it is when these photons get here. The sun is directly behind the moon during a solar eclipse. The reason it is directly behind the moon during a solar eclipse is because light is absolute. There is no delay. Slam dunk. Let me have a word with AI this evening. You don't understand the science, guys. It isn't possible. It's a paradox. It is not possible. It's actually quite stupid. 8 minutes and 20 seconds, right? Eight minutes and 20 seconds for the sunlight to reach the moon. In that 8 minutes and 20 seconds, we have spun on our axis by 2.08 degrees. The sun cannot be directly behind the moon. Look, I tell you what, you can paint this, get all of your colouring crayons out and start painting pictures, all different colours, and see if you can make it work. If you can, there is something wrong with you. It's illogical. We wouldn't ever see the sun in the sky. It's impossible. And once more, slam dunk. I'll be back later. Laters.